Hello, my name is Major Brian Matheson. I'm a family nurse practitioner with trauma and critical care at the Center for Sustainment Trauma and Readiness Skills in St. Louis, Missouri. The tech talk today is on 3D printing for healthcare modeling and simulation. I have the unique opportunity to be on cadre at the SeaStars St. Louis. It is one of 3 primary training missions in the continental United States. First of which is in Baltimore, the next is in Cincinnati, and the last here at St. Louis University Hospital in St. Louis, Missouri. Our primary training objective is to train active duty and reserve airmen in trauma and readiness skills prior to combat theater deployment. My background is I've spent approximately the last 15 years in trauma and critical care medicine. My primary research is in trauma modeling and simulation, and I have no financial disclosures. "3D printing has been used by the manufacturing industry for decades, primarily to produce product prototypes. Many manufacturers use large, fast 3D printers called rapid prototyping machines to create models and molds. Companies that use 3D printing for commercial medical applications have also emerged. Specifically for the manufacturing industry, as you can see, the automotive industry is becoming made famous for their large automotive prototypes. Healthcare, as we will talk about further, is also utilizing it for surgical planing, education, and custom implants. Lastly, because 3D printing technology is rapidly becoming easy and inexpensive, consumers are now becoming one of the largest users of 3D printing. As we'll discuss further, there's a variety of options for building your own 3D printer, but also for outsourcing it. "3D printing has been around since the early 80s. Charles Hull invented 3D printing, which he called stereolithography. He had a bachelor's degree in engineering physics and was working on making plastic objects from photopolymers in California. Soon after, stereolithography utilization of a .stl file format began to emerge. Later, he founded the company 3D Systems, which developed the first 3D printer. Since then, many other companies have developed, some of which are Stratus, Z Corporation. Nonetheless, each of them were built on Hull's work and advances. From a financial standpoint, it initially was very costly to utilize a 3D printer. Now, over time, simple models can be purchased for under $300. More complex and sophisticated models cost up to $2,500. Lastly, you could build a 3D model with a budget of $1,000. Nonetheless, 3D printing is currently a $700 million industry. Only $11 million is invested in medical applications. In the next 10 years, 3D printing is expected to grow into an $8.9 billion industry, with $1.9 billion projected to be spent on medical applications. So how do we do 3D printing? What are the basics? Initially, we obtain a CT or MRI images from an actual patient. Once these are obtained, we generate DICOM files from the original images. These DICOM files are modified and repaired using commercially available software into what is known as STL, or stereolithography polygonal mesh file. Thereafter, these STL files are sent off for 3D printing once again by use of an in-office printer, or as we outsource it on the web. Some of the current manufacturers, from a commercial standpoint, of 3D printers are Stratus 3D Systems, which is the original system developed by Charles Hall, and Z Corporation. Obviously, each of these manufacturers have patented their own 3D printers. Nonetheless, each of them looks similar to the one in the bottom left. As previously mentioned, there are also budget 3D printers that can be built in your home or office for somewhere near $1,000. Some of the websites, as mentioned here, actually will guide you through building this printer. If you're not feeling up to building a 3D printer with the previously mentioned websites, luckily someone has capitalized on this. Thus, for consumers who have difficulty printing 3D models themselves, several popular 3D printing services have emerged, such as Shapeways, Thingiverse, My Mini Factory. Each of these websites are ones in which you would send your STL files to, and they will format, build the model, and send it back to you for a fraction of the cost. Now that we have the basics and the history of 3D printing, how is it going to pertain to us? And what is the current research that is going to support our endeavors? Ellen O'Brien et al. Undertook this endeavor and reviewed 68 articles on 3D printing that was specific for medicine. From the 68 articles that identified by her review, 3 major themes evolved. 1. 3D printing of patient-specific models for preoperative planning. 2. Printing training devices for direct use in simulation-based medical education. And 3. Printing molds for simulation models that are then used to cast non-printable materials such as soft tissues. Granted, this is just one researcher's review of 68 articles. Many opportunities exist for further research and advancement of 3D printing. Nonetheless, I found this a substantial review on such a novel topic. Of the 68 articles that were cited, 33 of them specifically employed 3D printing to create and manufacture models for education and training. Some of the areas of expertise that these were utilized were neurological surgery, urology, otolaryngology, Kosaka et al. also showed that 3D printed models assist not only with preoperative planning, but also a useful deliberate practice of surgical techniques in the simulation laboratory before working with actual patients. Further research is needed to determine if 3D printed simulation models will lead to measurable improvements in surgical techniques. Nonetheless, Kosaka has identified an area in which modeling and simulation practice may be useful. Another researcher, Parsons et al., looked further into developing advanced laparoscopic suturing skills with the use of 3D printed material. Subsequently, they cast silicone into 3D printed molds, allowing for improved tactile responses during suturing skills training. Some of the direct conclusions that were found regarding the studies demonstrating that 3D printing for biomodels and physical simulators can be an effective tool for training were outlined. Considering cost, realism, efficacy, and positive impact on education, the authors collectively presented a strong case for continued research and study. For example, Balestrini et al. Directly quoted as, "The models produced are accurate and can represent all parts of the human anatomy, including soft tissue, at a price point that allows widespread use." Also, Warren et al. Directly quoted as saying, "Surgical trainees need multiple attempts to learn essential procedures. The use of these models for surgical training simulation allows trainees to practice these procedures repetitively in a safe environment until they can master it. Thus, theoretically shorten the learning curve while standardizing teaching and assessment techniques of these trainees." Another researcher, Longfield et al., mentioned 3D printing allows for a training experience that until now has not been feasible given the lack of cadaver temporal bone availability. Our prototype model does not replace cadaver simulations, but a large step towards generating a realistic replacement where cadaver models do not exist. Overall, I feel these are pretty strong quotes by multiple researchers to assist us in building a modeling and simulation program based in part by 3D printing. Another success story came out of University of Minnesota, where they are developing a more realistic airway trainer with the use of 3D printing. This research was funded by the U.S. Army Research Laboratory. And they found that many of the airway trainers that they currently use do not closely resemble human anatomy in their geometry and physical properties. With that being said, and with the lack of cadavers, they realized that most mannequins do not accurately represent the human anatomy, either in geometry or physical properties. This is further solidified by a study in June 2012 in the Journal of Anesthesiology noting that airway anatomy of 4 high-fidelity patient simulators and 2 airway trainers do not reflect the upper airway anatomy of actual patients, thus having a substantial negative impact on airway training. Given this, University of Minnesota Medical School utilized Vitrea visualization software to segment the tissue and airspace in the scans. These were printed on a Fortis 250MC 3D printer. Models were built, as well as a more realistic version of the cervical spine. These 4 prototypes were then provided to the Army for evaluation. The 3D printed prototypes accurately reproduced live human geometry and used materials that closely simulate properties. The reaction from the Army was that this was the most realistic trainer they had ever seen, and that if it was available, they would be the only trainer they would use. In the bottom right-hand corner, you can see 3D printed models that were used for their prototypes. Another case study is by Dr. Chai at the National University Hospital Aesthetic Plastic Surgery Center. He's been utilizing 3D printing since 2008. He utilizes 3D printing skulls for preoperative planning, subsequently reducing the time and energy needed for complex facial reconstruction cases. He states that at least one trauma patient a day has been helped by model produced by the 3D printer that his university has built. How can the military benefit from the aforementioned information regarding 3D printing? I think that the utilization can be multifaceted amongst the education and surgical planning domain. Primarily for this course would be used for modeling, simulation, and training. I could foresee building 3D printed models based on real injuries seen on CTs or MRIs, and subsequently allowing our soldiers or airmen to utilize these models during training in conjunction with high fidelity simulation, task trainers, didactics, etc. An example of this would be if we had a 35-year-old male status post 15-foot fall. We obtained a trauma scan, and his chest shows flail segments, pneumothorax, and pulmonary contusions. Currently, we can run this on a high-fidelity simulator and look at the physiology, or we can allow the patient to practice on the task tray. But how great would it be if the students could see, hold, and manipulate those injuries? For example, the flail segment on the bottom right-hand screen, we could build that in 3D printer and allow the students to feel, touch, and see how that interacts with the lung. Same way with the pneumothoraces, pulmonary contusions. I believe this will help better visualization and theoretical conceptualization of tube thoracostomy and injury patterns. Other ideas would be solid organ injuries such as splenic and hepatic lacerations or traumatic brain injuries. Each of these could have 3D models that are built in cross sections so the students could feel, hold, and touch and see these types of injury patterns. I think this goes along with another article by Giovanni Biglino. During this study, they systematically identified usefulness and applicability of three-dimensional models. The study targeted parents, patients, and physicians. Many of the parents during this study actually said that it was incredibly useful to our understanding to be able of the anatomy, physiology, and surgical planning that was going to be undergone. in comparison to having a physician draw a sketch. And unfortunately, I feel a lot of times, despite our high-tech simulation models and task trainers, it means a lot for a student to be able to hold the actual injury pattern in their hand and manipulate it. Future uses, I think, are widespread. The future of 3D printing in healthcare is diverse. I think we will see it multifaceted across multiple domains. Some people say that we are less than 20 years from a fully functioning printable heart. Obviously, given my excitement for this issue, I think that training and simulation in 3D printing will continue to explode, or at least that's my hope anyway. Another article mentions in situ printing, where they're actually printing living organs during an operation and subsequently implanting those. Much of this is pretty hard for me to conceptualize. Nonetheless, even with the utility of live human tissues being printed, I guess that this may be possible in the foreseeable future. In conclusion, three-dimensional printing is a relatively novel technology that is growing at a rapid rate. It has utility in manufacturing, healthcare, and hobbies. It's now more affordable than ever and is beginning to solidify its position as a learning modality in healthcare simulation. I truly appreciate you joining me for this tech talk. Certainly my knowledge on this subject is growing, and I don't consider myself an expert. Nonetheless, I'm excited about where these topics may take us in the future. Here's the following references. Thank you.